Have you ever looked up at the sky and wondered why clouds aren't always white? While pure white clouds are common, the sky often presents us with a palette of colors ranging from gentle grays to vibrant oranges, and even ominous greens. This essay explores the fascinating reasons behind this variety. We'll uncover how light interacts with particles in the atmosphere, and how different factors like sunlight angle and droplet size affect cloud color. Clouds reflect many things about our atmosphere, including the conditions they form under. By examining cloud colors, we can learn not only about the weather but also about the physical laws that govern our environment. This journey into the science of cloud colors will reveal that these everyday phenomena are far from mundane.
When sunlight enters the Earth's atmosphere, it interacts with molecules and small particles present in the air. This interaction involves both scattering and absorption of light, processes that are crucial for determining the color of the sky and clouds. Primarily, the scattering of light by tiny particles in the atmosphere explains why we often see white clouds. The color of light is determined by its wavelength, and when light hits the small droplets of water in a cloud, it scatters in all directions, mostly as white light. However, depending on the composition of the atmosphere and the presence of different particles, different wavelengths of light are scattered differently. This results in various colors being seen under different atmospheric conditions. This scattering is more pronounced when light passes through a greater thickness of atmospheric particles. This is often the case during sunrise and sunset, where the sunlight travels a longer path through the atmosphere, scattering short wavelength light, like blue, and leaving longer wavelengths, like red and orange, to paint the skies at dawn and dusk. This interaction is not only a delightful display but also a revealing glimpse into the atmospheric conditions.
It is a widespread belief that clouds are naturally white, but this is a simplification. The truth is that clouds can appear in a variety of colors, and understanding this can challenge and enrich our understanding of cloud dynamics. White clouds occur because the droplets or ice crystals within them scatter the light of the sun equally across all wavelengths, which combines to produce white light. However, when clouds contain larger particles, or when they are thick enough, they can appear gray or even nearly black. This is because the particles absorb more light, preventing the scattering that produces the white color. This variation signals different weather conditions, such as the potential for rain. Moreover, the angle of the sunlight, the cloud's thickness, and its altitude can all influence how we perceive its color. For instance, a low-hanging cloud at sunset may absorb more red and orange hues, appearing differently than it would at midday. This complexity shows that the color of clouds is not just about aesthetics, but also about the physics of light and atmospheric composition.
Several factors influence the coloration of clouds, including the angle of sunlight, cloud elevation, and the size of water droplets or ice crystals within the cloud. The angle at which sunlight hits a cloud can dramatically alter its appearance. For example, during sunrise and sunset, the sun's rays pass through a greater thickness of the Earth's atmosphere, capturing reds and oranges more effectively. Cloud elevation also plays a crucial role. High-altitude clouds are more likely to appear brighter and whiter because they reflect more sunlight before it passes through the atmosphere. In contrast, lower clouds tend to receive less direct sunlight and can look darker or take on colors from the surrounding environment. Lastly, the size of the droplets or crystals in a cloud affects its coloration. Smaller particles scatter light more effectively, resulting in a lighter, whiter appearance. Conversely, larger particles tend to absorb more light, giving the cloud a darker, denser look. These physical differences are not just visually striking. They also help meteorologists predict weather patterns and study atmospheric conditions.
Understanding the colors of clouds is not just an academic exercise. It has practical implications for weather prediction and atmospheric science. Different colors often indicate specific types of weather. For instance, deep gray clouds can signify impending heavy rain or storms, while bright white clouds might indicate fair weather. Meteorologists use the color and type of clouds as part of their toolkit for predicting weather. Observations of cloud color along with other atmospheric data can help forecast local weather conditions more accurately. This is crucial for planning everything from agricultural activities to disaster preparedness. Moreover, studying cloud colors can add to our understanding of the Earth's atmosphere and its processes. It helps scientists track atmospheric pollution levels, understand air currents, and even study climate change effects. Thus, the study of cloud hues is a window into both immediate weather and broader climatic conditions.
The colors of clouds offer more than just a visual treat. They are a narrative of the atmosphere's tale, told in hues of light and shadow. This essay has explored how interactions between light and atmospheric particles create a spectrum of cloud colors, influenced by factors like sunlight angle, cloud elevation, and droplet size. We've also seen how these colors can help predict weather patterns and reflect atmospheric conditions. As we continue to look up at the sky, let's do so with a deeper appreciation and curiosity about what the colors of the clouds tell us. Engage with the world above and beyond, and let the ever-changing canvas of the sky inspire questions and provide answers about our fascinating planet. Embrace the curiosity that comes with observing the skies, and continue exploring and learning about the natural phenomena that surround us. The sky is not just a limit, but also an open book waiting to be read.